What we're going to do now is just give you a really quick introduction to UML. Literally just enough UML to let you draw exchange content models for basic NIEM work. So again, this is not a big class in UML. There are plenty of them out there. This is a quick introduction so that you can get an idea what it's all about. But please don't think this is the be-all and end-all of UML instruction. It's really not. It's a lightning quick introduction. The basics of UML class diagrams are class and attributes. The classes are the boxes. They represent cohesive real-world objects, nouns if you will, and the structure of said objects. The classes then are made up of attributes, which are characteristics or defining properties of the class. So the attributes are chunks of information about the object that the class represents. In this case here, what are the classes and attributes shown? I'll give you a sec to eyeball it. Well, the classes are pretty simple. The classes are the boxes, the objects. There's a mammal, a person, an address, a person name, and a street. Those are all classes. The attributes are the things inside the boxes. For a mammal, we've got sex, height, and weight. And the sex is a string, and the height and the weight are integers. For the person, there's an education level, and that's a string. The person name is a first name and a last name, which are strings. The address has a city, state, and zip, which are all strings. Remember, zip codes aren't numbers. They're strings. They're just strings that consist of numbers. And then the street is another object, another class, with a street number, a name, and a street direction. UML can relate classes through generalization. That indicates inheritance from a general object to a more specific version of that object, and it's indicated by a closed-end arrow. So take a look at this diagram. Where does the generalization occur? Give you a sec to look at it. In this case, the generalization is the mammal class being a generalized version of person, or viewed conversely, person is a specialization of mammal. So if you're a person, you're a special kind of mammal, and you'll inherit all the things mammals have. You'll inherit sex, height, and weight, but you'll have additional things special to a person, like an education level. Composition is one way in which UML shows where one class contains another class. Classes contain attributes, chunks of data, but they can also contain other classes, and it represents that with an arrow with an open head, as opposed to the closed head for generalization. Now for composition, the contained class does not have a life outside of the association. Its existence only makes sense in the context of it being inside the thing it composes. So in this case, what's the composition? Give you a sec. Okay, the composition is the person name. It's that arrow with the open arrowhead and the closed diamond as the base, because a person name really doesn't have any meaning outside of the person whose name it is. I mean, unless there's a person named Tom Carlson, that name Tom Carlson has no meaning. It doesn't really exist outside of the person to which it refers. And we show that in UML with an arrow, open arrowhead, and black filled diamond at the base. You may be wondering, what's the one with the open diamond at the base? Well, let's take a look. The arrow with the hollow diamond at the base shows aggregation. Aggregation is a whole part relationship. It says this one class is made up by these other classes, and then they're an aggregate. They're an aggregate because the classes that make up the aggregation have a life outside of the class that they help make up. So in this case, where is our aggregation? That's right, it's that hollow diamond arrow pointing from address to street. An address is made up of a street address, but the street address has existence on its own. Regardless of whether you're talking about a street address as part of a person's address or not, that still location on the street still exists. So this has life outside of the context of it being part of this person's address. Associations are means for showing a generic relationship between classes, and it's indicated by an open-ended arrow with nothing at the base, just a unidirectional arrow. So what is the generic association here? Well, in this case, it's that person-address association. That address is associated with the person. And you don't have to name them, but in this case we've named it. We've given it the name residence to give us a little more information about the association. This address is associated to the person by being this person's residence. So we see the simple association arrow, but what if we need something more complex? What if we need information about the relationship itself? Well, UML has something for that. They're called association classes. An association class contains information about the relationship itself while pointing at the different objects using association arrows. So what's the association class here? It's the new piece that we've added. It's that person-employment association. And it associates a person, and that association arrow is labeled as employee, with an organization, which is labeled as employer. We need more information than just an employee-employer relationship. We wanted to have employment start date and employment position. So by making an association class, we're able to have the class itself hold information about the relationship itself. Association classes also give you a means to indicate n-ary associations. In other words, associations between more than one kind on each end. Instead of a one-to-many, it's a many-to-many, and association classes allow you to do that. Then finally, we have cardinality. Cardinality documents the quantitative aspect of associations. In other words, how many things you have associated to how many things. And how we do that is by showing a number at each end of the arrow. And that's indicated by a 0, a 1, or a star being as many as you need, kind of like unbounded in XML. So in this case, what cardinality do we see? Well, we see a number of them here. For the person employment association, we see that it's a one-to-one with the person and a one-to-one with the employer. So we're basically linking up one employer and one person for the purposes of the exchange shown here. For person and person name, similarly, we have one person to one person name. Same thing with address and street. One address to one street. But we do have something different with person to address. In this case, we're allowing for every one person 0 ... star. That means 0 to as many as you need addresses for that same person. And those addresses would all be in this model shown as residences. So that's the idea here, cardinality being shown by the numbers at each end of the arrow, taking values of 0, 1, or star to indicate in an unbounded however many you need type situation.